Hello, welcome to this lecture video. So today we're going to talk about problem solving and reasoning. So I am teacher Melai, and let us start with the core idea of this topic. So it is that mathematics is not just about numbers. Much of it is a problem solving and reasoning. Thus, our topic is problem solving and reasoning. So for the outline of this topic, so we have actually here subtopics, which includes inductive and deductive reasoning, intuition, proof and certainty, Polya's four steps in problem solving, the different problem solving strategies, mathematical problems involving patterns, and the last one is recreational problems using mathematics. So in this video, we are only going to consider the first topic. So that is the inductive and deductive reasoning. Okay, so what is a inductive reasoning and what is a deductive reasoning? So, inductive reasoning is the process of reaching a general conclusion by examining a specific example. So, in other words, it is from specific to general. While for deductive reasoning, it is the process of reaching a conclusion by applying general assumptions, procedures, or principles. Or in other words, this is from general to specific. So as mentioned, inductive reasoning is from specific to general, while deductive reasoning is from general to specific. Okay, so let's have an example number one. So predict the most probable next number. So in this given, so if we are going to consider now the values here by analyzing it, so we have 10. So to 10, 20, 30, and then 40. So we observe here that there is an increase of 10 from the first term to the second term. So 10 plus 10 is 20. So again, 10 is added to come up to the next number 30. And 30 is again added to 10 to come up with 40. So with this, we conclude that we are also going to add 10 to 40, and that is 50. So the process that we consider here, or that we use here in analyzing for us to come up with our conclusion that the next number is 50 is actually inductive reasoning, because of course we analyze it by terms to the next terms and to the next terms before we came up into a general conclusion that the next number is 50. So example number one is an example of inductive reasoning. Okay, let's consider another example. So this is example number two. So scientists often use inductive reasoning. So for instance, so we have here the picture of Galileo Galilei. He used inductive reasoning to discover that the time required for a pendulum to complete one swing, called the period of the pendulum, depends on the length of the pendulum. So Galileo did not have a clock, so he measured the periods of pendulums in heartbeats. So the following table shows some results obtained for pendulums of various length. For the sake of convenience, a length of 10 inches has been designated as 1 unit. So this is now the table that shows the length of the pendulum in units and its corresponding period of pendulum and heartbeat. So as we can observe here, so if the length is 1, the period is 1, the length is 4, the period is 2, the length is 9, the period is 3, the length is 16, the period is 4. So the task is to use the data in the table, and of course to use inductive reasoning to answer to answer the following question. So number one, so if a pendulum has a length of 25 units, what is its period? So of course, we have to observe what happens to the value. So as we can see here, it seems that the value of period is squared to obtain the length. So 1 squared is, the length is 1. 2 squared is, the length is 4, or vice versa, wherein it is the period is the square root of the length. So the square root of 9 is 3, the square root of 16 is 4. So if the length is 25, the square root of 25 is 5. So this is how the pendulum look like. So the period of, let's go back. The period of a pendulum is the time it takes for a pendulum to swing from left to right and back to its original position. So the method used is again inductive reasoning because we analyze it by specific parts first before we concluded that the answer for the question is the period is 5. Okay, let us consider example number 3. So for this example, we are asked to use deductive reasoning to show that the following procedure produces a number that is 4 times the original number. So to do that, so we have to open our board, which is the paint. So we're going to use the paint as our board. And side by side, we are going to look at the instruction here. Okay, so the instruction is to pick a number. So let's say our number is n. So pick a number n. And the next, multiply the number by 8. That is 8n. Add 6 to the product, 8n plus 6, and divide the sum by 2. So it is 8n plus 6 over 2, or this is 8n over 2 is 4n. 6 divided by 2 is 3. So we have 4n plus 3. And the last step, and subtract 3. So 4n plus 3 minus 3 is equal to 4n. So here we were able to conclude that the number that is produced is 4 times the original because this is 4n. So the method used is deductive reasoning. Okay, next. Okay, so for this exercise, our task is to determine whether each of the following arguments is an example of inductive reasoning or deductive reasoning. So number 1, or the first argument. During the past 10 years, a tree has produced plums every other year. So last year, the tree did not produce plums. So this year, the tree will produce plums. So what do you think is the first argument? Is it inductive or is it deductive reasoning? So in our first argument, what we are trying to see here is specific first before we concluded that this year there will also be plum. So it is actually, yes, inductive reasoning. Okay, next. All home improvements cost more than the estimate. So it sounds very general. So the contractor estimates my home improvement will cost 2 million pesos. Thus, my home improvement will cost more than 2 million. So here, it is started with a very general statement that states that all home improvements cost more than the estimate. So that's the general. So it's from general to specific. So argument number 2 is a deductive reasoning. Okay, next. All art is an imitation of nature. Music is art, therefore, music is an imitation of nature. So sometimes when we encounter the word all, it sounds of course that we are using a general statement. So it's actually from general to specific again. It is deductive reasoning. Next, the chair in the living room is red. The chair in the dining room is red. So it's specifically in the living room and is specifically in the dining room. The chair in the bedroom is red. So specifically in the bedroom, then all the chairs in the house are red. So it is specific to general. So it is, yes, you are correct. It is inductive reasoning. Okay, next. All muscles are made of living tissue. All humans have muscles. Therefore, all humans are made out of living tissue. So this is again from general to specific. So it is an example of deductive reasoning. All musical instruments make sounds, airplanes make sounds, so it's specific. Therefore, airplanes are musical instruments. So it's again deductive reasoning. And the next, Jennifer always leaves for school at 7 o'clock a.m. Jennifer is always on time. Jennifer assumes then that if she leaves at 7 for school today, she will be on time. So this example is from specific to general. So it is again inductive reasoning. Okay, so these are the references. Thank you for watching.